Your second lesson for the week is finding resultant vectors using the parallelogram method. Previously, you found the resultant vector by using the triangle method, but the triangle method won't work here because both of these vectors start at the same initial point. We can see that both vector B and vector C both start at the origin 0, 0. So we have to use what's called the parallelogram method to find the resultant vector. And so all we're doing is creating a parallelogram. In order to create a parallelogram, we need two sets of opposite sides that are parallel. And recall that parallel lines have the same slope. And remember that slope is basically just rise over run. So let's look at the slope, or rise over run, of vector B, and then I'm going to take that same slope and move it over to the opposite side to create a side parallel to vector B. So I can tell that vector B goes down 4 and over 2. Remember, you could just draw like a stair step, like a staircase to show the rise over run. And then I'm going to create the same slope over here on this opposite side. So let me go ahead and erase this extra markings. And I'm going to trace that other side with a dashed blue line. So I would need to make this line go down 4 over 2 and have the same length as vector B. So you can tell by this dashed line, it has the same length and it's going down 4 over 2 from this terminal point of vector C. Now I just need to draw the parallel side opposite of vector C, and I'll do that in red. So if we started with vector C, which you could have, let's just look at the slope of that line. So vector C is going up 5 over 9. So from the terminal point of vector B, I need to go up 5 and over 9. And so as you can see, we created a parallelogram. And what's neat about this is the resultant vector is the diagonal created by this parallelogram. So whenever you do your IXL, your resultant vector is the only thing you need to graph. You're not going to create these dashed lines that gave you the parallelogram. Those are only going to be there, or you're going to have to think about where they would be in order to get this resultant vector. Okay, let's look at some other examples. So once again, both of these vectors, vector B and A, start at the origin, and we need to create a parallelogram in order to find the resultant vector. So let's just start with vector B. I need to find the rise over run in order to create the opposite parallel side. So I can tell that vector B has a slope of -1 over 5 because it's going down 1 over 5. So over here, starting at the terminal point of vector A, I'm going to go down 1 over 5. Which is what I'm doing in this dashed blue line. Then for vector A, I can tell that my slope of this line would be down 8 over 3. So -8 over 3. So from the terminal point of vector V, I would go down 8 over 3, which creates this nice parallelogram. So whenever I go to graph my resultant vector, I would start at the same initial point of 0, 0, and then just draw that diagonal of the parallelogram. Your passcode is Tiger King. Alright, moving on to the last example. We want to find the resultant vector for adding C and D. So let's go ahead and draw that parallelogram. Let's just start with D. The slope of D is going down 5 over 2. So it'd have a slope of negative 5 over 2. Let me draw that in red. So starting from the terminal point of vector C, I would need to create a line that had the same slope of negative 5 over 2. Now let's do the opposite side of vector C. And I can tell that vector C has a slope of 1 over 9. So from the terminal point of vector D, I would create a line that had the same slope of 1 up 1 over 9. Now just draw your resultant vector, which is the diagonal of this parallelogram. Always start off at the same initial point as your other two vectors and end on the opposite side of that diagonal. Alright, hope you guys have a great week, and I will talk to you soon.